So your name goes at the top, and this is period 1, and we are on page, I forgot already, page 7. Oh yeah, the paper is on the counter. Yeah. So midpoint formula, when we talk about midpoint on a coordinate plane, we have both coordinates x and y, x coordinate and a y coordinate, and I want to find the point that is where on that segment? In the middle. So we can find the distance between the x's and then do what to find the middle? What do you think we would have to do to that x coordinate to find the middle part of it? Divide it in half, or take 1/2 of it, divide it by 2? Absolutely. What about for the y's? Would you do the same thing? Yes. So actually what it is exactly that. You're taking the average of the x's, because you're going to add the two numbers, divide it by 2, and add the two numbers and divide it by 2. So you do it for both the x's, and remember x's come first. It does not matter which x coordinate you put first because you are adding them, and addition is, what's that word, commutative? Yeah, so the order doesn't matter. But I like to think, add them, divide by 2. That's exactly it. Midpoint isn't too tricky. It's the distance one where it gets a little confusing, but you guys got this. I believe in you. So we're going to take the two x coordinates, add them, divide by 2, and we're going to find the middle x. So what would that be? What do you think? 1 for x? Yeah, I got 1 for x as well. So we're going to find where the 1 coordinate is. So it looks like it's going to be right there. And then you got 1/2. That does look about right. So add the y's, -1 plus 2. And -1 plus 2 is 1. So you can either write it as a fraction or as a decimal. Sometimes decimals are easier to visualize graphically. So that is our midpoint. So there's 2 ways to see these problems. One way is to see it graphically like we have the first one, and the other one is to see it in a word problem, or without a graph, I should say. What is the coordinate of the midpoint of AB? Notice that there's a hat on AB where it's a segment, with the endpoints at A, -10, +3, and B at 2, -2. So I'm going to label my x's, and those are 0.1. Label my points as xy, and that's 0.2. Go ahead and do that. I'll pause. And then your y's. What do you guys get? 4 and 1/2 again? 1/2 is a common one. I get, yes, -8 over 2 and +1/2. You can reduce that -8 with -4. And that's your endpoint, or that's your midpoint. Questions on this? Pretty simple. If when in doubt, just think average the x's. So add the x's, average the y's, add the y's, divide by 2. Add them, divide them by 2. So distance formula can also be that simple. Do you guys know Pythagorean Theorem? there's two ways to do this. We're going to talk about this using Pythagorean theorem first. I'm going to show you with a couple colors. So graphically, it's typically easier to see it using Pythagorean theorem, but then it is kind of hard other ways. So I've got my two colors. Camera's not really picking up the green and the purple. So my cat is named Pythagoras, and whenever you use, do you see him up there? So grumpy on the window. I put him right there. So he's watching over us. Yes, I moved him. It was getting kind of crowded over there. But now I can look at him and you guys can look at him looking at you. He is the sweetest kitty ever. But whenever Pythagoras, my cat. Oh. Pythag, because he is a straight up gangster. So Pythagorean theorem is a squared plus b squared Oh yeah, but we're gonna write it right here first, equals c squared. Yeah, you can write it actually here too. So you can use Pythagorean theorem, a squared plus b squared equals c squared. But we're going to derive the distance formula using this. So we're going to find the distance formula using Pythagorean theorem. So in this case, my a is going to be the distance between the two x's. So what is your a here? How many does it go? 1, 2, 3, 4, 5, 6. Did I count correctly? Is it 6? Yeah. So your a is 6, and then we're going to square it. Our b is going to be the y distance. 1, 2, 3. So how many is our y? Yeah, 3. 3 squared is equal to, and then c squared is going to be actually our distance. This is c. This is b. Forgot to label it. And so we're going to get our c squared, and then we're going to have to square root it. So what is 6 squared? 36 squared. Oh no, sorry. I added a square after. And then what's 3 squared? 9 equals c squared. And then add those together. 45. And then to get rid of the square, we do the opposite. We take the square root. And this is where we're going to decimalize it, because whenever we're talking about length, we like to have it as a decimal. So my calculator, I'm going to hit second square root and then 45. So yeah, let me show you on my calculator what it looks like. This calculator is one of my favorite ones. I'm going to hit second and then the x squared button and then 45. It writes it as a simplified radical, but I don't want that. So I'm going to press the 2 arrows. If you have another calculator that's similar to this where it writes it like this, you should have like either an S to D, S and then the 2 arrows D, or 1 arrow D. That means standard to decimal. Or maybe F to D, which is like fraction to decimal. I don't know, something like that. Yeah, I got the same thing that Jay got, which is 6.7 or 6.71 if you wanted to round it that way. But I'm good with 6.7. So that's the formula, but we can substitute in what everything actually meant in terms of x's and y's. So your a change was actually the difference between the x's. So what we would do there is we would write x2 minus x1 squared. That was how we got the change in the x's. Your b was your y change, so I'm going to put plus the square root of, so parentheses, y2 minus y1, got us c squared, which is actually my distance. So I'm going to write d squared. And then to get regular, like just the distance, regular d, we would square root everything. And I'm going to do that, but I'm going to reverse it. So d is equal to the square root of this hot mess. Oops, I forgot a square. Oh, thank you. Yeah. Yes. Yep, this one we would do the coordinates. I find it easier to remember the squaring, like the Pythagorean theorem. So if you think of it as steps and not the formula, subtract the x's, subtract the y's, right? Just that. Subtract the x's, subtract the y's, and then plug it into Pythagorean theorem. That's very easy. I know that this is kind of a struggle for a lot of people, but when you break it into Pythagorean theorem, it's not a struggle as much. But I think it's because the formula itself is really intimidating, but sometimes we really like formulas. So if you are the person that likes formulas and you're good with memorizing it, go for it. Memorize that formula, plug and chug. More power to you. I do not have that power. I mean, I remember the formula, but just because I use it so much. Let's go ahead and find the distance. And so I'm going to say d squared equals, we're going to subtract the x's and we're going to subtract the y's. So what I'm doing right now is I'm plugging it into the formula, but I'm going to actually just use Pythagorean theorem, but flipped. What is the distance between the x's? So I'm going through. I didn't read the problem. I guess I should read the problem. Because what is the length of EF with the endpoints E and F? Okay, so E is at -2, 3. F is at 5, -3. Let's go ahead and subtract the x's. -2 minus 5. That's it. And then subtract the y's. How would I write that one? Yeah. It would be positive. Oh, you're going backwards from what I was doing. Yeah, you could do -3 minus 3 if you want to. Or you can do 3, or you could have written 3 minus -3. Either way would be fine. The order, because we're going to square it, the order doesn't matter. I have a feeling we might need to do this one again, but that's okay. So I get d squared equals, what's -2 minus 5? -7, and then -3 minus 3, -6. When you square things, they just go away. The negative goes away, I should say. So -7 squared, that's the same thing as 7 times 7. Yeah. And then 6 times 6. Yeah. Add them, and then you gotta square root them. What's 49 plus 36? Yeah. And then square root that. Doing it in my calculator as well. That one does not simplify, so I needed to press the 2 arrow buttons right away. What do you guys get? Any decimalize that answer? Yep. Yeah, 9.2 or 9.22. I'm going to say 9.2. Okay, what do you think? that okay? Yes. Okay. I want to pick. I will show you the top part of my notes. I'm going to pick one question that is different, and it's where we have the other endpoint. Actually, I'm going to give you guys a chance to try these first. Try one. You can try two as well. It's the same idea. Sure. Two. Two. Three is a good problem as well. And then 4 is going to be one that I want to go over with you guys. And then these guys are the distance ones. So try 1, 2, 3 if you can. Try your best. Number 4. Number 4 is not the same type of problem. It is another endpoint midpoint problem. You're looking for the endpoint that gets you this midpoint. So I would like you to try that. And then we've got some distance problems. So I want you to do 7, 8, 9. So try those ones with your group. And then when we get up to 4, it's like about, I'm going to give you about 5 to 10 minutes. We'll see how long that takes us. And then we're going to try number 4. I'm going to pause the video though, and then we'll resume when we go over number 4. So for number 4, I was able to go around and check you guys. You all looked good for the most part. I think I am recording it now. Hopefully I am. For number 4, GH has an endpoint of 2, 7 and a midpoint M at 5, 1. What is the other coordinate of the endpoint H? So I'm going to visually draw this, but it's just going to be like a number line. So I know that it's a segment GH, and I have G at 2, 7. My midpoint is in the middle at 5, 1. And then my other endpoint, which is H, I don't know. How would I find the x coordinate and the y coordinate of my other endpoint, knowing the midpoint and the endpoint? What do you think we would do? You think what? Multiply instead of add. If I plugged it into the formula, you would end up like multiplying and then adding the change. But it's actually simpler than that. Your distance between the x's is going to be the same. So we're going to duplicate it. How many do I go from 2 to 5? How many do I have to add or subtract to 2 to get to 5? 3. So I'm going to add 3. I'm going to do that again so that we're, yes, multiplying by 2, but add it to 5. 5 plus 3 is 8. That's exactly right. So all you're doing is you're doing it again. And then the same thing for the y's, yes. Yeah, we're going negative, so minus 6. We're going down. So 1 minus 6 is negative 5. Very good. That's it. What do you guys think? That's boring. I mean, it's better than being like super complicated. And it's like, nope, not too hard. Okay, that's it. So now you know how to do everything.